Welcome to Session 15, Polynomial Operations and Identities. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to control signs while adding and subtracting polynomials, to use identities and common factors to avoid unnecessary expansion, and to verify degree and leading term as reasonableness checks. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Terms organized by exponent make like terms and polynomial degree visible. Scan powers before coefficients. Only terms in the same exponent column combine, and the highest surviving exponent determines degree after cancellation. The key distinction is this: control signs while adding and subtracting polynomials. Then connect it to the second goal. Use identities and common factors to avoid unnecessary expansion. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Order terms by descending powers. Identify the object being changed and the requested result. Step 2. Distribute subtraction across an entire polynomial. Use a separate line so signs, units, and restrictions stay visible. Step 3. Look for a GCF or identity before expanding products. Work efficiently without skipping an operation. Step 4. Check degree, leading coefficient, and a simple numerical input. Whenever possible, verify with evidence independent of the original working. Signal 1 is same binomial appears twice. Respond by remembering, factor the common binomial. Name the response before calculating. Signal 2 is conjugate factors. In that case, use difference of squares. The form tells you which tool fits. Signal 3 is polynomial subtraction. Remember, add the opposite of every term. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Simplify 2x minus 5 squared, 2x plus 5, 2x minus 5. Restate the target and identify the most important part of the routine. The first move is, both terms contain 2x minus 5. This changes the form without changing the meaning. Next, factor 2x minus 5, 2x minus 5, 2x plus 5. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. The bracket simplifies to minus 10. State what the transformed line tells you. Complete the argument. Multiply minus 10, 2x minus 5, equals 20x plus 50. This is part of the solution, not decoration. The final answer is 20x plus 50. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. What is the remainder when p equals x squared plus 2x plus 1 is divided by x minus 2? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. Visible decision is easier to inspect and correct. F-focused hint. Use the remainder theorem and calculate P2. Use it to repair your setup rather than guess. An accepted answer is 9. Explain why it works and name the first step that would expose a common error. Centralness is control signs while adding and subtracting polynomials. Combine it with the discipline to use identities and common factors to avoid unnecessary expansion. Finish by remembering to verify degree and leading term as reasonableness checks. Turns a calculated result into a justified answer. Reflection. Which clue made factoring faster than full expansion in the challenge? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes with a degree check. Keep the work readable, check it independently, and carry the routine forward.